Greetings YouTubers, I'm Rick the Tech Enthusiast here with the next Elegoo lesson number 6, Active Buzzer. In this lesson we'll learn about the active buzzer and how to use it with the Arduino, so let's get to it. First we'll need to briefly talk about buzzers in your kit. There are two piezoelectric buzzers that look pretty similar, one that has a sticker on it and the other without. You'll also notice that one with the sticker is sealed around the pins with some kind of black epoxy. I think that the tutorial calls this black tape. And the positive pin is longer. The other has what looks like a little circuit board exposed. So the one we'll be using in this lesson is the buzzer with the sticker, sealed underneath and has a longer positive pin. This component is the active buzzer. The other is a passive buzzer. So what is the difference? Well, the active buzzer has a built-in oscillator circuit to create an alarm sound when 3 to 5 volts DC is connected, while the passive buzzer needs an AC signal to create the sound. It's the AC frequency that creates the pitch. Caution: connecting DC voltage to the passive buzzer may result in damaging the component. The tutorial goes into more detail about the piezoelectric buzzers, so I encourage you to check it out. For this lesson, we'll need the following items from your kit: the Elegoo Arduino UNO R3 board, active buzzer, typically this is the one with the white sticker on it, 2 female to male jumper wires, and that's it. On page 65, you'll see the following schematic. And here's my version. Notice that we're simply going to connect the female ends to the active buzzer and the male ends to the Arduino board. Super simple. On page 66, you'll see the wiring diagram. Please note, the sticker is shown just for part identification. In previous lessons, I show you the physical circuit first, kind of explain it and whatnot, but this one's so simple, let's just jump right into the code. As before, we'll load the recommended sketch provided in the tutorial. Looking at the code, you see the active buzzer is connected to pin 12, and that we set the pin mode in setup to output. The void loop consists of an endless loop with 2 for statements. Each for statement sends different pulses to the active buzzer by quickly turning it on and off with different time intervals. The first is 1 millisecond apart and the other is 2 milliseconds apart. Note, the only way to stop this is to basically unplug the Arduino. Okay, let's upload the code and test it out. Here's the circuit. You can see the LED flashing as the code is loaded and we get the alarm sound. Perhaps that's why we should keep the sticker on to help muffle the buzzer. Notice the 2 varying alarm sounds. Okay, enough of that. Unplug the Arduino when you're satisfied. Excellent. It worked just as expected. Well, that's it for this lesson. Oh wait, perhaps we could do something cool. How about a Morse code translator? Let's come up with some design criteria. We'll use the Arduino with an LED and active buzzer to indicate the dots and dashes. Now, I just recently learned that these are referred to as dits and DAWs. We'll need to use the serial monitor to get user input. We'll want to see the dits and DAWs outputted to the screen, and we'll try to set the timings so that they conform to Morse code rules. Well, Wikipedia is not the worst place to start, but I found this timing rule. Looks like it's all based off a single unit of measure. That shouldn't be too hard to program. And it has the International Morse code for most of the characters and some punctuation. Okay, here's a schematic I came up with. I'll keep the buzzer connected to pin 2 and add an LED to pin 6. I'll connect the ground to the ground bus and use a 220 ohm resistor to the LED. And I found there's a 150 ohm resistor and I'll connect that to the active buzzer to kind of quiet it down a bit. And here's the breadboard wiring diagram. We just need to make sure that the buzzer's long pin is connected to the positive side. And if you want your dits and daws louder, just jumper directly to the positive lead on the active buzzer. Okay, let's take a look at the code. Okay, here's the code. It's a bit more complicated, but we'll go over it and see if we can make sense of it all. We begin with some global constants. I like to declare my pins as constants so I can't accidentally change them in the code. This is followed by a variable string input, which I set to nothing. Next, we have the global Morse code variables. This is to define all the time spacings. I include some details on time spacings in the comments above. Since everything is based off a single unit of time, we can define all other time intervals as a function of the first unit. Later, if I want to speed up or slow down everything, I can change one variable, the MC unit, and all other timings are adjusted accordingly. Now here I have my global arrays. We haven't exactly gone over arrays yet, but I'll leave some links below that you can review later. Simply, arrays are like spreadsheets with a variable name and numbers to identify all the little boxes associated with it. I'm defining the array with square brackets and no numbers between them. That's because I'm taking advantage of the compiler being smart enough to figure out how many boxes the array needs when I'm defining the array. These string arrays hold various sequences of dits and daws for each letter or symbols. And the trick is to keep them in order according to the ASCII table. You see, each character has an associated numeric value, which means I can also perform math with them. So determining what sequence a letter has is as simple as subtracting the letter capital A or little a from a given character that gives us the location. So if I have an array of letters with, let's say it's defined as 26, this means I have a variable with 26 boxes to store stuff. Now arrays start with box 0. So if we're looking for a letter, say for example, the letter G, which has an ASCII number of 71, and then I subtract A, which has an ASCII number of 65, we get a value of 6. But G is the 7th letter in the alphabet, you may ask. Recall, we start at 0, and if we count 7 spaces over, we get to box 6. And we get whatever is in box 6 for the letter G. This works the same way for L punctuation, U punctuation, and the special case arrays. Finally, we get to the void setup. I use the Serial.begin statement with 9600 for the baud rate. I next perform the pin mode functions to set the buzzer and LED pins to output. The void loop starts by asking the user for input using a simple Serial.print statement. This is followed by a while loop checking to see if the serial available function is something other than 0. So while there's no user input, it loops through doing nothing. After it receives user input, it's assigned to the string input using the string input equals Serial.read string function. I then echo the input to the serial monitor so that the user can see what they just entered. And I pass the serial input to the DoString function. Here's an important note. The order of the functions is important to the compiler. Any function that calls upon another function had better be below those functions it called, or you'll get some kind of compiler error. So if we scroll down to the DoString function, we see 2 local variables, a char ch value and an integer string length, which is set to 0. String length is then assigned the length of the passed string. This is followed by a for loop. This for loop uses a local variable x and increments it as the code goes through the string one character at a time and assigns it to the ch value. Then it checks to see if the char value is a space, a carriage return, or a null value. If it's a space, it does a word delay. Otherwise, it does nothing. If it's a regular character, then it sends the char value to the function translate. The translate function's purpose is to determine which string array to look at for the Morse code sequence. I tried to do this in an ASCII numerical order, starting with the L punctuation, then numbers, then U punctuation, capital letters, lowercase letters, and any special case, which is basically the underscore. Anything else sends an invalid character to the monitor. So if I didn't catch it anywhere else, an invalid character is sent to the monitor. Once the appropriate array is discovered, a little math gives us the location of the sequence string we need to send to the doSequence function. Now the doSequence function gets the passed string and checks it for dits and das and don't cares, which basically is don't translate. For each dit or da, it sends the appropriate delay to dit or da function. The dit or da function simply turns on and off the buzzer and LED using the delay value passed to it. It then returns back to the function that called it, which in this case is the doSequence function. The doSequence function starts where it left off. Here it checks if x is less than string length. If so, it does a parts delay and continues looping until it finishes the sequence. It then returns to the function it called it, in this case, the translate function. Now back to the translate function, it's already at the end, so it returns to the function that called it. In this case, it's the DoString function. So we're back to the DoString function, and it continues to loop through all the characters in the string, passing them to translate, and so on and so forth until it completes and returns to the void loop. The void loop has a small delay, adds a carriage return, clears the input string, and starts the process all over again. Wow, I know that was a bit heavy on the coding. Let's upload the sketch and check it out. Well, of course, we need to start the serial monitor so we can use it with the sketch. So now you can see the layout of the circuit. I have the active buzzer connected to pin 12 through the 150 ohm resistor. The LED is connected through the 220 ohm resistor to pin 6. Both are connected to the ground bus, which is connected to the ground pin on the Arduino. Now let's type in a message. Greetings, YouTubers. That worked awesome. Let's try something harder. Let's think of something hard. How about money, because when I use a dollar sign, let's do the hashtag awesome, exclamation point. Let's put some quotes around that. And send lots. Let's do a apostrophe. Let's do an asterisk. And let's put in a fake email address here at gmail.com. Of course, that's not a real address. Let's put in a slash, just kidding. And a little equal signs, and then we'll kind of make a little smiley face. I don't know about you, but that's really very cool. Well, that's it for this lesson. I hope you've enjoyed learning a little about the active buzzer and my Morse code translator. If you like this sketch, be sure to let me know in the comments section below. I'll have additional links for other interesting videos and the code for this project also in the show notes below. Join me next time for Lesson 7, Passive Buzzer. If you like this video, don't forget to rate and subscribe. I'll try to put out a new video each week. Thanks and see you next time.